Our video for today is on multiplication of complex numbers. So let's start with multiplication of a complex number with by constant. So when we multiply a complex number with a constant, so suppose z equal to a plus ib, a complex number. Then if you multiply this z by some constant alpha z, so this constant can be any real number, this is equal to alpha, then our z is a plus ib, and this can be alpha times a. So we multiply the real part by that constant plus I alpha b. We multiply the imaginary part also by that constant. So an example is, suppose we have z equal to 7 plus 2i. So we want to find 2z. So this is 2. Now instead of z, we write 7 plus 2i. Then we multiply 2 by the real part, 2 times 7 plus, then we multiply 2 by the imaginary part, 2 times 2i. 2 times 7 is 14, 2 times 2 is 4, so 4i. Similarly, if we have a z equal to minus 2 plus 5i, and we want to find minus 4z, then we write our minus 4 here. Instead of z, we write minus 2 plus 5i. Then we multiply these two. Minus 4, we multiply it by the real part, that is minus 4 times minus 2 plus minus 4 times 5i. So we then multiply it by the imaginary part, minus 4 times minus 2 will give us 8, positive because of minus times minus, plus minus 4 times 5 will give us minus 20i, and plus and minus is minus, so we'll have 8 minus 20i. Now we want to multiply a complex number by another complex number. So let's say we have z equal to a plus iota b and z2 equal to c plus id. Then z1, z2, that is z1 times z2 is a plus ib times c plus id. And to do this, we multiply a by c, which is ac, and then we multiply a by d, which is plus, because of this I, we'll have iad. Then we start with b, we multiply b by c, ib by c, then plus ibc, then we multiply this ib by d, then this will be, we have 2i, so this will be I square bd. Then we have ac plus, there's an I here and there's an I here, I can factor out the I, then we have AD plus BC. Then we should remember that I square is equal to minus 1. So if we substitute it there, we'll have minus 1 BD. So we have AC plus I, AD plus BC minus BD. plus and minus is minus. Then I can collect the like terms, those without the I. Then we have AC minus BD plus iota AD plus BC. And from here, this is our real part of Z1 times Z2, and this is the imaginary part of Z1 times Z2. An example, suppose we have Z1 equal to, let's say Z1 equal to 3 plus 2i, Z2 equal to maybe 4 minus 3i, and we want to multiply these two. Z1, Z2 will be equal to, our Z1 is 3 plus 2i, Z2 is 4 minus 3i, and multiplying this, we first multiply 3 by 4, 3 times 4, then we'll multiply 3 times minus 3, so plus 3 times minus 3i, then we multiply 2i and 4, then we multiply 2i and minus 3, so plus 2i minus 3i. So 3 times 4 is 12, 3 times 3 is minus 9i, 2 times 4 is 8, so here is 8i, plus here 2 times 3 is minus 6 because of minus here, and I times I is I square. So we'll have a 12. Here we have minus 9i, 8i. We can, they are imaginary numbers. We can add them together. Minus 9 plus 8 will give us minus 1i, which is minus I, plus minus 6. We should remember that I square equal to minus 1. So we'll have minus 1 here instead of I square. So we'll have 12 minus I minus 6 times minus 1 is 6. And now we can add the real parts, which are 12 and 6, the parts without the I. So 12 plus 6 minus I. And then we have 12 plus 6 is 18 minus I. Now suppose we have Z equal to A plus IB, let's call it Z. Then the conjugate of Z is changing the sign of the imaginary part. So here our imaginary part is B, then we change the sign. Since we are having plus, we change it to minus. So it will be A minus IB. So if you multiply Z, let's see what do we get when we multiply Z and it is conjugate. So this is A plus IB times A minus IB. To multiply this, we multiply A by A first, which is A square. Then we multiply A and minus iota B, which is minus iota AB. Then we multiply B times A. Then this will be plus iota AB. Then we'll multiply this IB times minus IB. So this is minus I square B square. So here we'll have A square. Here we have minus AIB plus AIB. They are opposite of each other. So this will be cancel each other. It will be 0. Then we'll have minus. We should remember that minus iota square is the same as -1. So this is -1 b square. And then we'll have a square minus and minus is plus b square. And here our a, we should remember, is the real part of z square plus b is the imaginary part of z square. So this tells us that if we have z and multiply by z conjugate, we can take the real part of the z square and plus the imaginary part of the z square. An example is, suppose we have z equal to 4 plus 3i. Then we know that z conjugate is 4 minus 3i, to change the sign of this plus 3 to minus 3. Then z times z conjugate is, we can take the real parts of z square. So let's see, the real part of z is this 4. This is the real part of z, and the imaginary part is this. So we take the real parts of z using that formula, the 4 square plus the imaginary part, which is 3 square. And this is 16 plus 3 square is 9, and this is 25.